Alright, looks like about time to get started. So, hello and welcome to Bug Free Productions. We have we're gonna do some drafting of the thing, but in honor of Video Game Day, we're gonna do some video game dev stuff and also help catch us up on the timeline for the camera script. So, with that, we'll do a short recap and look over what we started last time. So I'll go ahead and pull that scene down. And what we should have been working on last time would have been the camera. We created the camera folder, created Racer Camera Context, created Racer Camera Manager, and Racer Camera State. State, which defines what the states are going to look like. And then we have in here our states. I went ahead and just made these in the off time, so if you don't have these, don't worry about it, and we're probably not even going to use any of them except the, what we should have had last time, I think, was the accelerate and the idle. And that should be good for right now. That's all we're going to be needing. Along with those, these three here. The camera manager, cam context, and the racer cam state. So, we'll just open up where we left off, and we'll head on down to our Visual Studio. And our Visual Studio will be looking a bit like this. I have some extra states opened up, so let's eliminate grind. Idle, we'll still use that. And then move state context SCO. Just making sure audio is coming through. Cool. Racer move context. So we'll look at that a little bit. We may or may not connect this yet, but let's get our vector math in first. So we need to go to our racer camera state, and in here should be a calculated new camera targets that we started. Along with, and I'm just going to show this quick. So I did this to set up the other states I created. You don't have to have all these in there, but you should have accelerate and idle in here. So go ahead and add those if you haven't. Under, I even made a region for changing states. Let's just change our states, and I hooked them up with the context, which is not racer move context, it's racer camera context. Let's move that down too. And to set that up, all I did was, nope, I just minimized that. So you should have these ones in here as accessors, so public camera state, current racer state, accelerate, and also idle. And then we should also have, so that should be in change states. We went through, I believe, and did this. So you should have the accelerate method through the idle method, change state, and make sure to have this line in here as well, where it checks its Boolean value. And those are different for accelerate and idle, just slightly. Same logic, but different access. Different properties we're accessing. And we'll go ahead and minimize that again. So we don't need to change the states right now. And then I went ahead, and I believe we did this also, as we racer, yeah, let's pull this over. Racer camera state should have accessors, and I added all these for all the states I have. You can go ahead and do that for up till, I think grind is the last one I'll do in video, possibly. But those ones can get added to the access pools. And we'll pick up here where we left off. So new look 2 was being equal to ARC cam anchor dot forward. So we are getting the forward of ARCC plus the anchor position, which will say basically mean in world space we're moving 1 unit of it to its forward direction. And here we're doing look from in the negative way, so it's starting and going backwards 1. So that's pretty good. And then what do we want to do with that? So next thing to do with that would probably be, I'm also gonna go, I want it to have 1 up as well. So I'll probably do n look from dot, and it's hard to tell, right? Because how is it going to be changing this XYZ is actually not going to help me at all, because that can change when you rotate. So that's not very good. I probably need to, that's what it is. It's up. So I need to use, and we can actually just add this onto the end, actually, which is what we should be doing, so that we don't have another extra line that's just more typing. So we should also add the ARCC dot up, and we need to go cam anchor dot up. So we add the up direction, so it goes back and up, and then in coordinates with this position. So that's all pretty good. What do we want to do here then? So if it's calculating this should work, right? And we decided we wanted it in the update frame because cameras need to rotate and move on update. So we should have that here. The other thing is we could have this updated less because this is a target vector. The tweening has to be done every frame, but our calculation probably doesn't. Although I think we should still put it in update, because if we put it in fixed update, it's going to run on a physics frame, and physics frames are pretty busy as it is. So we might do better to just put it in update. So since this one can't have an update, what that comes down to is that we go to we're going to have another actions. So if we go to methods and we create an actions, I'm not going to create a region for actions just yet. TIONS actions methods, action methods, and we need a public virtual void, I'm going to call it uActions, so that I don't write update anywhere in the word, which causes autocomplete to think you're trying to say update. So I'm going to say, or what was it? Was it action? Let's try that again. ACT. Actions is not a keyword yet, somehow. So I'm going to go actions U. U for update. Because it'll just be easier to read a little bit. And we're going to go calc. But yeah, so this is in here. This will also need eraser cam context. So we'll put that in there. And then what does this do? This just calls calc cam target. And we put in a parameter of ARCC and executable line. So that should look pretty nice. Just calling what we just did, which does the calculating. All of this is not assigned out though, if you'll notice. New look n form. This is not accessible to anything after this has been calculated. So we either need to make this a return, which how feasible is that looking? That could be feasible. We could either make this return, or we could make this assign out to the top here, and when the other thing calculates, it would just be able to find it. So for that idea, we would have to pull this out of the method and have that exist up there, which camera eraser state, which would be located in the state, which would not be great. So what I would actually do is say that the context is supposed to hold this information and that it would return, but you can't return two vector threes, right? Not through a single method. I mean, you can. What would that be? That would be, easiest way to do that would be using an out. Out, and it's going to be out vector 3, and we can do look 2. This would be not n, but a look 2. And then we can do comma b. And this would be a look from. So if that's a look from, how does that look? There's still some error because this hasn't been assigned yet. That's fine. So what I would do from here is then just change this to a, and get rid of our declarations. So sometimes you find a new way to do things that's a little better, and I think this will be easier in the long run. So let's go ahead and also put this in the section here. And we're going to put that a look to and a look from. So that should work. Why is that screwed up? Because it doesn't have out. And is this okay? And because this is passed in with the out and it's not assigned in this method, that throws an error, which is going to be a pain. So the other option is to, yeah, because we got to return that out somehow, right? So we can't exactly do that. Oh, it must be passed without keyword. Okay, no problem. That's not a problem. Great. And I forgot out down here. And that looks all good. So with this being all good, that means we can just keep going and we can look at more. So basically out returns a vector and assigns it to that vector. So that variable that's coming in as a vector3 is going to be assigned when it goes back out. Since it's still assigned before this method ends, I guess it's not a problem. So that's good. I was kind of worried that wasn't going to work there. And then we can go to our camera context. And he's a mono behavior. So what we can do with his mono behavior is, well, after enable, because that's just kind of how you set it up, we're going to do a protected, virtual void, and it's going to be an update with that and corals. And what does that do? So if we got curly brackets here, now we can call our current state for RCS that, and we can go actions, update. So our update actions, no, not define, mistype, line end, and what does actions need to run? So it needs this context, it needs an out variable. So we need a vector3 to store here that could then be accessed by somebody else because we want it to pretty much come up to here and be part of this context because the state might update it, and we don't want every state having its own set of vector3s. That's kind of dumb. It would take up some memory and just be kind of inefficient to access it that way. For example, I wouldn't read it correctly that way. So let's go ahead and create. We have camera objects. We need just vector3s. Let's try just putting them in here for right now so that we can, or underneath this region actually. And I'm just going to go v3 objects. And they're going to be protected, vector3, and they're going to be from, and probably even do cam from vector3.0, protected vector3 cam2, and this should be 2. No, it shouldn't be. I've been labeling that wrong. It should be regular. So this is 2. to and out cam from. So it'll set those every update because we're passing them into this method that has the authority to change these two vectors that we pass into it. So that's nice. From here, what do we do? So that's running every time. So we have it updating. Now we need to think about how we actually change the camera position and stuff. So that would probably be in racer camera state. We have the calculation of position. And now we need to define how it's going to move towards the target positions and rotate towards the targets. Move to the target from position and rotate to look at the target to position. So what are our steps in doing that? Our next part would be probably another method that could look at, that would use references that it gets from camera context to calculate that, because we wouldn't put that method in we didn't put that method in the racer camera state. Well, we would put it for changing, and we're basically just going to change it based on our settings. So we could either put it in the camera context or the camera state, but it makes more sense for the camera state itself to have that, because a camera state might handle it differently, and it might not actually calculate, or it might calculate it, but it might just reassign them to be the same vector if we don't need them to change. Or we just change our actions to not do anything. For example, in a later state, if we choose not to do that. So we'll probably need one here to move camera to position. So move camera to from position. We need to rotate camera to face to position. To position. And then from here, right. And actually, this much stuff is going to be in the manager that we were talking about. So if this can calculate where the camera should be and where it should be looking to, and that's stored in the context, sorry if I backtrack over myself a couple times here, but it's a little bit many steps. And then that gets stored in the context in our Laravel vector 3 objects, right? So then if we create some accessors down here, and I could use some, oh, that's not what I thought it was. So access to the vectors to and from position. So I'll just do that too. To and from position. And this is going to be public vector 3 I can actually make this virtual, but it's kind of dumb for this context. No puns intended. So it'd be cam 2, and that would be get return cam 2, and then public vector 3 cam from get return cam from. And if we have that, then what do? So we save up just in case. Save Control S, Control Shift S. So then this can go over to the Racer Camera Manager. And in here, can I get a, yep, I did save those to clipboard. So we want to move the camera to the from position. So, best way to do that is to tween its movement. So, I want it to move at a speed of percentages over a duration, or at least over a duration, but likely as percentages over a duration. And so that's going to be, just going to write that down. Percent duration over duration with buffer. Cool. We don't have to do the with buffer, but that just kind of makes sure that it doesn't move all the time, which can be a problem too. So Racer Camera Manager, I'd probably make a settings object, but since we're not at that point yet, like once we test this code, know that it runs, then we make settings objects. So since we don't really need this anymore, this is going to look towards something else. And actually just get rid of that altogether, because this will be accessed differently. Did I do this in the wrong script? Context. No, I just did it in this one as well. And here we go. So we want to do, let's do a public, not public, a protected T, protected virtual void move camera. Move camera, which takes in no parameters, is a method and runs on update, but just open some lines. So protected virtual void update move camera, nice. Okay. Yep, that sounds correct. And actually, let's think about that as well. I probably should have written down some notes and stuff for this, but we're just gonna wing it, I guess. Calculate cam target. So if we're in the camera state, we calculate the target, right? We take that in and we put out new cameras, or camera positions. Okay. So if we think about that for a little bit, when our body rotation occurs, right, our anchor will also likely rotate, and that's going to be a problem because now we're not on the same axis, which this does solve for, but doesn't. How do I convey what this problem is? It does so. If we wanted to do a spin out, we couldn't do a spin out still though, because it still calculates forward and front. And then also we don't get positions based on the calculated target. I mean, we will, but this has to run, some version of this has to be in every state. And when the anchor turns, it'll still have to run and calculate this. Oh, but we said we could reassign it. We could just access and reassign the vector to itself, which is fine. Because the other option is to put it in Racer Manager, where it calculates it and just gets values from the state. So it would basically get its settings for the state instead of having the state calculate it, which is equally viable. It's just a little weirder to me. There might be some numbers and optimization to look at there, but we'll continue with this one. Move camera. Yeah, because once you start using out, you have to assign those variables that go in. So you can't really just say we're not going to do that anymore. So maybe if our goal was not to necessarily force it to assign, a better option might be ref. Which I don't think is quite as fast as out, but it does allow us to reference something and also assign to it. So it just gives us a little more flexibility, which in this case might help us out in that term. Yeah, ref might be better to use in this case instead of out, just for that simple purpose, because we might not want to assign a new vector 3. It's got to be updated too, doesn't it? Yeah, it does. Just thinking through some options. Okay, yeah. We'll just have to deal with it being that way, or figure out something in here to do that. Then we got snake it all the way through, and that's just uncomfortable. We're just gonna move on with that the way it is. um, because we could always write another script to tell when the anchor is to update, like when it should rotate with the player and when it should not. Which might be a good one to have in the move racer camera state. Racer camera state could have an anchor lock. Let's do that. Public. VI virtual pool anchor is anchor locked. Get return false. Actually, default would probably be true on that one. For no other reason than there's going to be more states where the anchor is locked than there are states where the anchor is not locked. For example, idle, accelerate, dash, drift, all your pretty close to all your ground states, you're going to want that anchor locked. So there's just no point in having it be false by default because we'd have to override it in more classes than there are that we want, which is good. So that's a look ahead. So that leaves us adaptability to lock and unlock our anchor point, and that can help later. So that our assignment still takes place in reference to the anchor, but the anchor is not always locked to the direction you're going. So moving camera, well, we did that enough. We want our camera to move towards a position as a percent duration of the buffer. So up here, let's do tween vars. And where would that actually be? That would probably be referencing something in the racer context, but we'll test some tween vars first. We're gonna go private. Reason not protected. If it all completes, I'll take it. Float. No reason for any particular privacy setting because we're just gonna take this out anyway later, but we need something to use. Protected float of type, and this will be our tween time, which is going to be, I'm going to start with half a second. And we're going to have our protected float of call this change rate. Change rate, lowercase c. And that buddy's going to equal something like change rate. We're going to say 0.9. Let's go 90%. So this goal is to get about 90% change per frame until we get to about 0.5. And then we need a protected float buffer, which is equal to something like 0.2 works. It's usually pretty good. If you think about it in terms of units, a unit is equal to a meter, so this is essentially 0.2 meters. Pretty okay. Move camera. So that would be this guy goes on the camera object itself. So this is our position. So in that term, it is lowercase transform dot position is equal to, not camera main transform position, it's going to be equal to so it's direction, so it is its own position, transform dot position. And what additions do we put onto that? So transform position plus the direction it is towards the other object, which I believe is from -2. So it's transform dot position might be 2 minus from. We'll find out. Or I can just open my IK that I was working on. Where's your manager camera animation? Well, this is all rotation. That's not going to help us. 2 minus from or from -2? I think it's from -2. So it's going to be our racer manager is going to need it's not going to need this because it doesn't need to store those, does it? Would it need to store those? Not really, because it's already in the other state. It gets calculated every time. So doesn't really need those. Let's go ahead and continue then. Move camera, transformed up position, and it is going to need a reference to a racer cam context. So let's do we kind of need to look at our Unity setup then, don't we? Where in the world are we going to put our manager, right? So our anchor, we'll make an anchor script that goes here eventually. But camera, okay. Main camera, does this have the camera manager on it right now? Yeah, it does. Camera manager is not going to be on the same object that is the player body. So it's going to need a serialized field reference. And we're going to have to do that then in here. Serialized fields with a header that is of ref to actually let's just kill the header. This is a protected, and this has to be a this has to be of a vector. No. This has to be of a racer camera context and RCC. Not assigned by default. Can't be assigned in the on enable either. because it's not under the object. So let's say that there. Then we'll go protected virtual void update, move camera. And this guy can go RCC dot, and this is going to be our cam2 from -2. Cam from minus the transform dot position then we have transform position plus that. So that should be strictly the amount of units we go to get to that position. So it would move and lock pretty much exactly, so we could have just set the position equal. So where this becomes different is now we multiply this by a speed. So I'm going to go ahead and create another open in a parentheses and multiply this by our floats that we have up there, which are tween time, but not tween time yet, change rate, and multiply by the difference of 1 divided by tween time, So if you divide 1 by a decimal, the number gets bigger, and comes to the number that that when 1 is divided by becomes your decimal. So essentially we're saying I want it to take this many seconds because I multiply it by, or I say I want it to take the 0.5 seconds, and then that would give me 2. So it moves twice as fast as when we multiply by our change rate and our RC cam from, the direction. Yes, our direction from our current position. So that should work. That should all be good. And the last thing we need to do is if our distance, so that would be static vector3 dot distance parentheses with parameters is greater than a buffer. Then we do this thing. And what's the distance argument that goes in there? Well, that would be our transform dot position and our RCC dot cam from. So if these two vectors are farther apart than the buffer, then we go. Distance is always positive, I believe, because it's always in positive units. I don't believe it's ever in negative units. So that should work. Then we're going to have to go ahead and grab that, Control X, we're gonna have to go here and Control V. So then here's our tween time, transform.position, adding the direction multiplied by the change rate multiplied by the time, tween time. There's actually one more multiplier put on this, and that is because we're in update, we need to multiply it by the fixed time dot delta time. So that is the time that not fixed delta time, just delta time, because we're running an update. Cool, right? So then this should tween our position into the new position we desire. And it should do it with this method. Let's go ahead and try and see if we can get that to run first, because I don't want to so we need to go to our player bod, because we haven't added that yet. So we need to add the camera context. Erase your camera context. And why do we have to add it here? Well, RCM, racer move context. Doesn't that just populate when it runs? It doesn't? Or did something error out? Let's go ahead and get our racer camera context. Look at that. On enable, so we don't, but we can, because it's going to be on the same object. Let's go ahead and do that. So in our on enable, I forgot to add the so get scene refs, which are going to be a get component that is a type of racer move context, and that would be the thing called RCC. RCC is equal to does not exist in the current context. RCM. That's the racer camera manager. This doesn't have any reference to the racer move context. It has a reference to the racer cam manager. And when is that even used? Never. So that's not anything we actually use. So what was our error? Name RCM does not exist. Racer camera manager. Oh, was I? Let's check that. RCM has 0 references. It's just, yeah. So I think it's just that I ran it without that other thing. So if I go to main camera, scroll down, and put that camera context in there. We run play. What does it do? Raster camera context. The variable cam anchor has not been assigned. Okay. Cam anchor, I'm just gonna go whole body for testing purposes. Then we play again. Okay, so you see it kinda based on that position. It did move in. It didn't move in too bad easing wise either. That was pretty good actually. That looks really smooth. Can't save? Well, that's miss exit play mode to save scene. Okay, so that's looking really good. So we got a camera that kind of pivots to where it's supposed to be, which means you could actually make that fly in by just starting all the cameras in one spot for each player. You can have a player's camera start at like a racing flag and then come all the way down and stop there, uh, which could be a neat kind of little effect if you wanted to do that. Uh, yeah, so camera manager's working. So we just gotta tweak and tweak and tweak until we make it a little bit better. Um, if you wanted to leave it here, you absolutely could. That's pretty good. But my racer camera state, this bugs me, right? So, and why does this bug me? Because this is all, well, not technically hard coded. It's pretty close. These are all constant values. Because I just do the forward and the position and that sort of thing, and up, which is 1, which is the current position, which is forward 1, or in this case, back 1. So it's not great. It's not variable input at all. So what we actually want to do is probably create settings SCOs. So if I go back to like here, and I would call this like a camera state SCO, right? So let's go to projects and scripts and parameters, and in SCOs parameters, I would probably start boxing some of these up so that was a little bit easier on me. SCOs, body object, ground check. So in scripts, SEO params, SEOs, I would actually want to go ahead and create a new scriptable object. So we're just going to go create C# script. And this is going to be the RACER cam underscore SCO. And then we can open it. We can enter, enter, enter. And then date it. And it's going to be, and then it's going to be a namespace that I want to put in here. Namespace bugfreeproductions.arcade racer. And then from Arcade Racer, we can actually go and this down here. And then I just want to get rid of the update. Bars. DHODS. So accessors, why are we doing that? Well, just kind of wanted to have the access. So I want to do like serialized fields up here like I've done before. Serialized field. And this is going to be all floats probably, because we're dealing with vectors which are based in floats. And if we're doing floats, that means we need a public we need to use we can make this protected. And if we make that protected, well, what do we do next then? If we make this protected, then indeed we do have to create it with a name. So probably we'd have our distance. So we'd have forward distance by back distance. So let's go ahead and do a vector 3. And instead of where we added the dot up and the dot forward, we're going to create vector 3s that we can add. And while we still have to use the transform up and forward, we can now multiply the vector 3s. Yeah, we can now multiply the vector 3s. In a way that, and I think the way vector 3 worked is that vector 3s have, when you multiply a vector 3 by a vector 3, you multiply x, and then you multiply y's, and then you multiply z's. It's not a jumbled mess, because that would be ridiculous. Vector 3. So we process float, not a float, a vector 3. We process a vector 3, which is going to be our forward. So let's actually call this our cam 2. Cam 2 cam 2 set, and that'll equal vector 3.0 for no reason. And then cam from set, also vector 3.0, also for no reason, because we do plan to set this, but we just want it to be fully defined instead of poorly defined. So methods in racer cam SCO is going to be no methods just yet. So we have this and this, but I'm also going to rename this racer cam state SCO. And you'll probably start to see that I'm following another falling into a similar pattern that I did with the other one, right? So we'll have to allow the state to get these information and return it via the context all the way back up to the racer cam state. Through the racer cam context, which is not a big deal. It's a lot of typing, but it is the most accurate way I can think of right now. So that's what it'll have to be. Cam, this isn't quite right. public PE vector3, that's going to be cam2 set, and it's going to be get cam2, and I don't want to do a set. And public vector3 cam from set, return cam from set, control S. And from there, so we have those ones. That's our position information, right? We also probably want to set our target tweening and stuff. So let's go ahead and check out what that looks like. We had these guys, right? So control C, and I'm gonna go to raster cam. We're not gonna use move state SCO. Racer move state. Not gonna use that maybe right now. Racer move context. Come on. I'll go back to Unity and look at it, and I'm sure it's still up. Yep, there we go. Sometimes it's just impossible to remember where the hell you're trying to go. So instead of hard coding here, we'll probably also put these Alt Shift up, Control C, Control V. Alright, click down, get rid of that space. Okay, so a little fucked, but it's fine. Any rate. Our buffer is here, set to 2. So here's where I might start putting some ranges in. So a range of numbers between 0 and 1, and a range of numbers that's pretty much applicable to everything here. Pretty much applicable to all of these. They need to be decimal numbers because they shouldn't be above that, because I'm not going to want to wait 5 whole seconds for my thing to get close to my target position. Right? Cool. So racer cam state SCO. Cool. Let's do Control C. Let's go to cam context racer. It's going to be in the context, but also back arrow. Come on, racer cam SCO. We have to add one thing in here because we need it to have a asset menu. So we create asset menu, and we go parameters of, we're going to need the, what would it be? Is it file? File name equals string value. Scriptable object. And then it's file name, menu name equal, and that's also a string value. That's also there. And then just to make sure, let's flip Unity back. Maybe. Flip back to Unity and we'll go check out our scriptable params. Create a scriptable object that is racer cam state SCO. Great. And we can see this here and here and here. So basically, if we wanted it to just do the one, currently what it is doing, if we wanted to multiply by it and do this, we could. And that would just leave everything the same because we're just going to multiply by that vector we get. Right? So that's the idea there. And then this is just adjustable slider. So even people that don't do programming and stuff can come in and change these numbers a little more easily. This would be, I haven't seen a way that, I wonder how range affects that. Let's go see. Let's see if I can add a range in here. I can add a range, but what's that? Float int variables in script be restricted to a specific range. So if I did this, let's see what the result is. The result is nothing. The range has used range with float or int. It prints a different header. It gives me a header telling me why this doesn't work. Nice. So range only works with the integers and the method. No, the integers, floats, maybe doubles, probably not doubles. But good to know all, nonetheless. So now we need to add this into the context. We'll probably get it using these settings and then not continue with making all the settings and stuff. That'll probably be something that can be done probably off stream. So we'll be looking at that. And then we'll try and get our anchor pinned down and some of our other stuff pinned down. Because right now we still don't have certain other things we're going to need. For example, looking at the target point, it's still not going to look at anything in particular, which doesn't work out for us. So we'll need to get that done too. Let's continue with the next object then on our list, which would be to go here and okay. I might need just a second. So we have to go to this racer move context script, right? Or not move context. That's racer camera context. This guy needs a, if I can close another region, I'd love that. Yep. This guy needs an access to the SCOs, which I created a region for ahead of time, but did not actually create any. So serialized field, and this is going to be probably going to copy this and also give this a region, and not a region, a header. And save it that way. And then the object that's going to have this is a protected. The protected float. Is it? No, it's protected scriptable object. It's a protected racer cam state SCO, which cannot be defined currently, but must be named. And this should probably be, so we'll do idle, idle underscore shift SCO to designate its scriptable object, just so it helps my memory. Control duplicate, call this one accelerate. Accelerate, lowercase. This is okay. This needs serialized field, so I can serialize it. And that's all looking good, so I'm gonna go ahead and look at this. This looks good. And we're gonna be moving on to the other thing. Don't do that, Windows. Come on. Wait. Okay. Cool. Then we're gonna move over into Unity. We're gonna look for a couple things. So now we should be able to go to our player body, just go down, pull in our scriptable. Why isn't that there? Because it didn't save up. And then we can go look, probably. Hopefully see our SCO. And where's our... Let's rename it. So this should probably be called something like IDLE CAM idlecam SCO. Why idlecam? Because I think I just called these like idle param. Which I should probably rename those to make them more. But I'm also going to create a folder. This is going to be camera. Cam params. Cam param. Idle cam param. And then create scriptable object. Racer cam state SCO. ACCELERATE. Accelerate. SCAM underscore SC and O. And where's this guy go? So then we go accelerate. So we can change how those work. If I wanted to change the default, I could probably go change it to 1. Yeah, because multiply won't come out with the same problem as addition. It's more like masking at this point if we're only going up to 1. But multiplying will have more effect later. It'll have more effect later. All we got to do is keep going. and we go to here. So this should come in and be usable now. So the camera state, so the camera should be able to use those settings to multiply, and then also need to return them because we need them to do the rotation, because we still need some of those information for it. So what we'll need to do is in our camera, racer camera state, we'll need a variable that is going to be our, not a variable, need a method. So we'll need, let's just minimize some of these so we can look at some stuff. Move camera from position, access state bools. So this is Boolean. Let's rename AACC. This is crap. There we go. Let's create a new region. Region. Oh, I did that wrong. I did want to calculate the stuff here. Still. No, that's just comments. I was right to delete that. Region. This is going to be something called ACCESS via. Now the reason I'm doing it in methods, even though it clearly states that this is for access, is that I can't access this directly. Why is that? This is a C# state, right? The state is all just C# code. So it has no way to get serialized fields or mono behaviors or anything. We put all that stuff in the camera context. But what can it do? Well, it can return things that it has access to within the camera context. So if we look at it, we can do a public, and we'll do virtual just so we can override it later if we want. But it's going to be of type, and this is actually going to be a racer cam state SCO, because actually, yeah, just because it's easier than making multiple methods that return for this, it's going to be easier to return the SCO, which I think I did differently in my tweening script, so I might have to go back and simplify that. That's cool. Eraser cam state. So that would be eraser cam state SCO. SCO. Just treat it just like a accessor or a getter or a property, whatever you want to call it. Return, and we're actually going to need a racer move, RAC, racer camera context, ARCC. And why ARCC? Well, because he has our settings for the accelerate And the reason that's underlined is because I probably didn't type it into the RacerCam context, because I didn't add it to accessors. And we'll add it right under here. So hashtag region access for COS hash end region. And then in here, we're going to create a public, not virtual, because that's dumb, and this is meant to be a real accessor. It's going to be public racer camera state SCO. And it's going to be IDLE. Oh, it's got to be capital IDLE underscore SCO. Get return that one. Why is this one weird? Maybe I didn't define it upstairs. Yeah, I just misspelled it. Cool. So now those are should both be working. Awesome, right? So then we should be able to go back to racer camera state. This returns that scriptable object reference. So we go to camera context. Accelerate SCO. That returns that object, right? So I think we just want to get yeah, we should just have another public cam state. Racer cam state. Racer cam state. SCO. Not method. And this should be using get return and what does it return? The RCS dot racer cam state SCO. Which is taking in this. Alright, so this getter is usable by, let's just break that down for everybody. Called by cam external objects. Yeah, called by cam manager and external other external. That's good enough. Called by called by states. So these guys are used for the states to get their information. This is used for everybody else to get their information. Because if we just pass this guy straight to the cam manager, he can figure out what he's supposed to do based on that. So that provides us with our tween settings and all that stuff based on our current state via a reference that's just returned to us by something else that is already keeping track of all this information. So that's kind of cool. Meaning our racer cam state racer cam state. So whatever's in here, we're returning accelerate SCO is returned up. And then we're going to go ahead and take our actions and our calculation. Let's get some extra white space here. Even though it's in dark mode, it's still called white space. We have cam anchor forward position. So basically, I'm just going to wrap this in parentheses to maintain my assuredness. And then I'm going to multiply by the context, RacerCam context. It's not what I wanted. I want ARCC. ARCC dot. This is going to be racer cam state SCO. Just probably, well, this would be a good default one because then it'll always go with whatever you change down here. It's pretty good. So the SCO dot this would be 2, not 2 string. Cam2 set. That makes sense, right? Why doesn't that make sense? Operator cannot be applied to operands of type vector3 and vector3. So you can't multiply vector3s at all, huh? Well, that kind of sucks. That defeats the whole purpose of that, doesn't it? Well, let's go ahead and what could we do? I think I'd pretty much just have to look from dot x a look from dot x is equal to arcc dot, and this is going to be cam racer cam state SCO dot come on cam, okay, the SCO dot cam to set x and that's not quite right either, is it? Because it's a look to dot x multiplied by, we do it by multipliers, and a look to capital T, rename this one actions. Out parameter look to must be assigned there. So that's for the x, and then we just do that 2 more times. Back y, back y, back y, back z, back z, back z. That should all be good. Again, there might be a more efficient way to write this so that you don't have to do quite as much accessing and methods, but it does a pretty good job of it. Yeah, because there's a slight bit of access time on that. That's running every update, which isn't great, but it's usable. And we just do the same thing here. Let's copy this one. So this is kind of dumb. So as a default, it works really well. I might override this in the future methods just so that it accesses itself directly, because it seems kind of stupid to be going all the way up to move context and then all the way back down to this one. It seems like a big loop just to set this, but it should be all fine. So look, a look from x to cam set x, and this is going to be changed to cam from set, and we're going to go 3 times, and we're going to go y, and we're going to go y, and we're going to go y, like we ask ourselves all the time. We go z, Let me go Z. Let me go Z. Just like we try to every night. And this should be set to work well. Okay, what did I do? I missed the S. I hit Control A. Perfectly fine. And we're going to go ahead and look at our Unity once that loads up. So, now that we did all that work, we should see absolutely no change. There's a slight change. So why is it slightly changed? I have a feeling one of those STOs isn't quite set correctly. Accelerate, what's our settings there? What's our settings there? So they're exactly fine. It must be, huh. So we do see a change. Why do we see a change? We have 1, 1, 1. So 1 times the x, if the x is 0, should be 0. So if these are all 1s, there should be no problem, correct? But what we're seeing is it's now moving to like a zeroed position, but not on Z. It's weird. Because it's forcing it to, no. Because 0 times 1, Because if it's on -1, I'm not clamping it, which could cause, would cause that in my mind. But what it's doing, it's still using look 2. God, I don't like that. From? Yeah, I have a feeling that's what I screwed up. So I just forgot to change that. So that should work pretty good. So if we pull in here, we should expect it to go back to normal. So why is that not working? There's a null reference to an object. It's probably, maybe we didn't set the scriptable object on the bod. Player bod. Go down to the bottom. Yeah, that's the problem. Idle SCO. See what happens when we play it now. Now that has a reference. Yep, so it was just my references. But from was definitely a problem as well. So those two things fix that. And now we have this working correctly. And if I was to go ahead and change accelerate to be like, let's do a 5. It's going to move way up 5 units above where it should be. And designers could just set all that by themselves. They can use decimals in there, fix it up however they want it to be. Alternatively, you could like break this apart into floats, so and construct these vectors out of the floats that they enter in here. So we'd have like CTS, which would be cam2 set, and that would be, so we'd have CTS X, Y, and Z, and then you just make each of those a range of certain things you want them to be in range of. Could do some more cleanup work that's like make sure these vectors are so close within each other, like make sure the distance doesn't exceed this much and do a clamp if it does, stuff like that. But for the most part, this is looking pretty good. If you have semi-experienced Unity people, they're gonna be, for the most part, okay. It's looking pretty good right now. I'm thinking it's almost 50 after, so maybe we'll start wrapping up. Probably look at anchoring and stuff, not tomorrow, be Tuesday. So let's go ahead and pull open that other scene. So thank you for watching Bug Free Production. Remember to watch and follow on Twitch. Schedule's up on Twitch, 6 o'clock p.m. Tuesday, Thursday is code and variable things. Code on Tuesday and variable stuff on Thursday, depending on if I need to catch up or if we need to do some other fun content like Blender streams and stuff you can check out over on my YouTube channel. We did a few Blender type things and some game streams also. So those were fun, and we'll hopefully do more of those. Do some more variable stuff as well as that. So, and then Saturday is our art stream at 10, and that's basically just looking at it. And sometimes we do comics, although I'm gonna start doing some game art for the bike part of this I was working on. So that'll be fun to look at and have some fun time with. And we'll be back with this application dev on next Tuesday. So, as always, thank you for watching. And if you have any questions, remember to maybe head over to the comments on our YouTube video channel and put some comments in with either suggestions or questions about certain Unity things. That would be great. I'll see you all later, and as always, have a bug-free night.